So this video is going to be focusing on polynomial parent functions. Remember in the last few units when we had f of x is equal to x squared, where that was the basic quadratic and whatnot? Well, all that's coming back. So, starting from the beginning, a polynomial function is a function of the form, I am not going to read this craziness to you. I don't even know how to read that to you. So, take that as you will. But the coefficients, a with a subscript n, a to the n minus 1, and so forth, those are real numbers. But when you have a with the subscript n, it cannot be equal to 0. Alright? And then n just represents a positive integer. You can't have any negative exponents in this case. So, a to the n is called our leading, that looks terrible, sorry, our leading coefficient. Leading coefficient. So now in this box right here, we need to classify each of the polynomial functions by their degrees and then give its leading coefficient. So we're actually going to be looking at the numbers that are out front. Make sense? Cool. So looking at the first one, f of x is equal to 4. What's going to be the degree of this function? Well, since it is a constant function, the degree is going to be 0. Since after that 4, you could say that there is an x raised to the 0 power, and its leading coefficient obviously has to be the number 4. So now look at the next one. F of x is equal to negative f of x plus 1. Its highest degree has to be 1, since there is an implied 1 after that x. Its leading coefficient is going to be negative 5. So in case you haven't figured it out, the way you determine the leading coefficient is the number that's in front of the highest degree exponent. So in this case, for f of x is equal to 12x squared minus 11x plus 31, the degree of this polynomial, since it would be the highest degree, is 2. Its leading coefficient in front of our highest degree is going to be 12. And do that all the way down. So therefore, the degree of the next polynomial has to be 3. Its leading coefficient is actually a negative 1. Because after this minus sign, there is an implied 1 right there. Same thing right there, but it's not relevant to the problem. So now, next function. Our highest degree is going to be 4, and the leading coefficient that goes with x to the 4th is negative 3. Last one, our highest exponent is going to be 5, and the leading coefficient that goes with x to the 5th is 9. Pretty straightforward. So now, let's see what all those parent functions look like, but these should be pretty familiar. We've done these before. So first, let's look at a constant parent function. That would look like a horizontal line, since you have to have y is equal to some number. So that would look like f of x equals c, the c representing just some number. If it is a linear parent function, then it's going to be a diagonal that's going in the positive direction, and it cuts through the origin. That looks like f of x equals x. A quadratic is a parabola. It's a bad-looking parabola. There we go. And that's going to be f of x equals x squared. And then our cubic kind of has like an S-like shape. And that looks like f of x equals x to the 3rd. A quartic actually looks very similar to a parabola, though it tends to be a little flatter on the bottom. Let's see. There we go. So that'll be f of x equals x to the 4th. And then our quintic, same thing as x to the 3rd, only it's a little more spread out. Like how you can see it's a little flatter. And that would be f of x equals x to the 5th.